Okay, so everyone, welcome to our first Water at Wayne for 2021. We're going to wait a couple minutes, wait for people to come in, and then I'm going to go over some housekeeping rules. And after that, I'm going to pass it off to Dr. Papuga, Dr. Shirley Papuga, to introduce our speaker. So we'll get started in a few minutes here. Okay, so everyone, welcome to our first Water at Wayne of 2021. We're super excited for our series this year, and we're gonna just start off really quick with some housekeeping tips from some Zoom tips and housekeeping tips. If everyone can stay muted throughout the event, we would appreciate it, just so that Dr. Gerba or Dr. Papuga, or whoever is talking, will be able to, everyone will be able to hear them. We're going to ask everyone to keep their videos off throughout the event. And then the last item is we're going to have a Q&A at the end. So anyone who has any questions, feel free to send those to Dr. Papuga, Dr. Shirley Papuga. You can send those throughout the event, or you can wait until after the event, or after the presentation's over during the Q&A. And we'll make sure to get through as many as possible, if not all of them. So right now I'm going to hand it off to Dr. Shirley Papuga, who is a professor at Wayne State, and she will introduce Dr. Gerba.
Okay, hopefully you guys can hear me. It is my pleasure to introduce Dr. Charles Chuck Gerba, who received his PhD in microbiology from the University of Miami, Florida. Currently, he is a professor in the departments of environmental science and in the College of Life Sciences and Agriculture, and community environmental health in the College of Public Health at the University of Arizona. Sometimes affectionately referred to as Dr. Germ, Dr. Gerba has an international reputation for his methodologies for pathogen detection in water and food, pathogen occurrence in households, and risk assessment. He has been an author on more than 700 articles, including several books in environmental microbiology, and has been featured on numerous television programs and magazines, including Good Housekeeping. He is a fellow of the American Association for the Advancement of Science, American Academy of Microbiology, and the International Water Association. He has received numerous awards, including the McKee Award for Groundwater Protection Research from the Water Environment Federation in 1996, and the AP Black Research Award from American Water Resource Association in 1997. So without further ado, Dr. Gerba is going to present some research on wastewater epidemiology and disinfection of SARS-CoV-2.
Yeah, thank you a lot. Thanks for the opportunity to get to talk to you today. Basically, what I'm going to go is some of the work we did on wastewater epidemiology initially with SARS-CoV-2, and then talk a little bit about disinfection work that we've been doing also. We got actually started almost this time last year. We had previously worked with the original SARS virus and coronavirus survival in wastewater. So we were kind of set up, and we immediately applied to work in a biological safety laboratory 3 right away. So we were able actually to get in there before the clinical people did, to start working on the SARS coronavirus. Just to give you an idea of the breadth of what we're working on here, we're doing sewage surveillance for the virus, which I'm going to talk about in the first part of my lecture. And then looking at communities, cities like Tucson and other cities around the country, looking at monitoring the wastewater and how the levels of virus change relative to different interventions. And then we're looking at the infectivity of the SARS-CoV-2 in wastewater, getting more details on its survival, and then looking at UV light and chloramine disinfectant of the coronaviruses, and then persistent antiviral coatings and fabrics. So this is largely done for protective equipment for like wastewater workers or healthcare workers, looking at innovative approaches to that, which I wanted to talk about. The virus and concentration in sewage has been known sometime to be related to the number of cases in a community. This goes back more than 40 years when detecting in poliovirus in cases in communities has been done, particularly in Finland and Israel. They've been doing it since the early 1980, actually, they started largely to look at the introduction of poliovirus cases into their countries, but it's now used by the World Health Organization and others to look at vaccine effectiveness and trying to track down cases of polioviruses in developing countries like Pakistan or Afghanistan. And if they find the virus in the sewage and the wastewater, they can go in and vaccinate the people in that community. And it's been found in studies where they've actually flushed poliovirus down the toilet is what they did. And in some recent work with SARS-CoV-2, you can detect one case in 100,000 persons by testing the wastewater. Now, even though you think, well, how can you detect that fuel? Well, a person is excreting billions of viruses a day, and viruses tend to be retarded in wastewater systems. They're like sticky ping pong balls bouncing along the sewer line, so you don't get a bolus of them at one time. They found in Finland, if you flush the virus down a toilet, you could find it for as much as 4 days later at the wastewater treatment plant. And you can determine the success of failures of interventions or the success of interventions. And usually you can predict the number of cases about 7 days before they clinically are recognized. So you get a warning if they're increasing or decreasing. And you can identify, and I'll talk about this, facilities with infected individuals, and it's less costly, far less costly than clinical tests, where you can basically monitor an entire community of 100,000 with one test. So it does have advantages. Limits of the clinical test are what we found in the original SARS was limited availability. We were able to test for the wastewater within a week for the SARS-CoV-2 once we set up. And what about if a person tests negative on Monday and he gets infected on Tuesday? Will that show up or start excreting the virus? Asymptomatic carriers are usually not tested. We can actually monitor asymptomatic carriers by this method. And there's a long lag in reporting of cases too, often days. And you deal with the issues of false positives and false negatives too. So there are some advantages of it. Now, coronavirus, you weren't aware, are a group of viruses that cause disease in both mammals and birds. And usually it's a respiratory infection, usually mild. The coronavirus 229E is one of the common causes of the colds in the United States. So we get it all the time, but it's not severe. I don't know of any mortality associated with 229E. But severe cases like the original SARS and MERS, Middle Eastern Respiratory Syndrome virus, which is contracted from camels. And the name corona means it's like crown is where the name comes from. Now, the different kind of coronaviruses we study often are shown here with the SARS-CoV-2 taking all the attention. We actually do a lot of work with human coronavirus 229E because the Environmental Protection Agency will accept that for testing the disinfectants in lieu of SARS-CoV-2. So we do a lot of work. There's a lot of work you can do it because you don't need a biological safety laboratory 3, you can get away with a 2 rating. Now, it's an envelope virus, and it can survive several days in water, wastewater. We know from studies done with the 229E and the human coronavirus. So it will survive for a while. And it's excreted both in the urine and feces, definitely in the urine in infectious form and in the feces. You know, you often hear urine is sterile, but with many in virus infections, the infectious virus is excreted in the urine. So I think it's a misnomer to call urine sterile because you can excrete a lot of virus in urine. Now, what about the pandemic as we're progressing through it here? Currently, there have been like 440,000 cases almost, which now exceeds all the people who died in the military in the U.S. in the Second World War of it. Now we're past this initial. We estimated it in January it'd be 407. Now we're 440. So we're moving towards the Spanish flu, which was 675. It's estimated that sometime next month we'll be at 500,000 deaths due to the virus. So the toll is fairly large. I think we lose that perspective sometimes, the number of people who died from it. Now, some more, what's the advantages of wastewater epidemiology, as we call it? Well, one, you can cover an entire community, a potential bias. What do you mean by that? Well, some people will volunteer to get tested. Others will just stay home. They won't get tested. So, it's a voluntary situation. Where we're doing a community, we can test the whole community. Operational cost is a fraction of what clinical testing is. Early warning, you can't do that with diagnosis-based testing. Somebody's already infected. But we can support the idea of what's going to gaze, they're going to go up or down, and we can detect asymptomatic cases. And the testing capacity is fairly low. We have to have a large number of PCR instruments, for example, polymerase chain reaction, thermocyclers. We only need one to do a large number of samples with it. The other thing, as you can see on the graph on the top here, we'll start picking up signals before the number of cases peak. So we can have an early warning system, if you would, with this type of analysis. Basically, the process involves this is going to a wastewater treatment plant or a sewer line, as I'll talk about, bringing the sample back. Usually we bring back a liter, we test 100 mLs, bring that down to about 2 mLs. And then we use that in doing testing for the RNA. We extract it and do a polymerase chain reaction. Doesn't tell you whether viruses are alive or dead, but it is quantitative. Now, we found in a lot of recent work, the levels have been so high, we don't really have to concentrate it. We can just take the wastewater samples directly from the city or the wastewater from the dorms, and we can still get positives now. Now, there are clinical test kits, or I should say environmental test kits now, that have been developed that can test the wastewater directly, by the way, and they seem pretty good, some of these. We've gotten really good results of it. Now, there's a lot of this testing going on. I would say there's at least 1,000 samples worldwide being taken a day, and over 100 that I'm aware of are being taken at different utilities and test points in the United States today. So a lot of action. What we do basically is take 100 ml of wastewater, centrifuge it to move the solids. You will remove some of the virus on the solids, by the way, because it does attach very well. You can test the solids if you want to. We pass it through a filter to remove the bacteria, concentrate it using a Centricon ultrafilter centrifuge, and then do the PCR. So it's pretty simple. What we do at the university, we take samples and come in by 10 o'clock from the dormitories. We have our results by 3 or 4 o'clock today. So we can turn this around fairly rapidly now. Original studies were done in Amsterdam and Holland on SARS-CoV-2. They're looking for a certain gene called N2, and they notice again, they could have quite a lead time here of a couple of days where they saw the increases versus the clinical, which is the gray line here, reconfirming what was known with poliovirus, that we could actually get results fairly rapidly and before the peaks were occurring, and we could see the decrease with it. So a good way to monitor the community. Now, we've been doing this wastewater-based epidemiology at our wastewater plant called Agua Nueva here for almost a year now, actually 7 years, looking for different viruses, but intensely over the last year. And the stay-at-home order case count, and we had a stay-at-home order earlier in the last year, and we saw the decrease coming right away. It confirmed that it really did decrease the number of people infected, and again, it was confirmed by the clinical cases. Now, reopening of the economy was open, the stay-at-home order was released, and approximately 7 days, the virus increased again, and the case counts increased 2 weeks later. So we could see it coming. So the advantage, we saw the impact of the intervention, and we also saw the impact of release of the intervention of the increase in cases. And boy, every holiday we've seen it. After Memorial Day, we saw an increase in the wastewater cases, increase, Independence Day, Labor Day, Thanksgiving Day. the Christmas holidays too. We could see it coming each time. We got a 1 week warning in the wastewater before they started seeing the first cases increasing in the community. So it's worked very well. And we're currently modeling all this effort to develop predictive models that could be used in the future, hopefully for other pandemics or issues of monitoring the wastewater. A lot of our efforts been done with Brad Smith, who's an environmental scientist at London, Virginia, in that he's been modeling that along with John Hopkins data using our work in that. But Pima County is where I'm located, looking at the daily number of new cases versus the titers of the virus in the wastewater. And it models very good. If you look at the R value, it's 0.92. So we've been able to model really quite well the number of cases we're seeing versus what we're finding in the wastewater in terms of the concentration of the virus. And we're currently preparing a manuscript on this. It worked out quite well, much greater than we had hoped, because we were worried about asymptomatic cases maybe interfering with these results, but that did not seem to be the case in terms of predictive value. And the model was very good, positive correlating with total infection and new case data is appearing as they appeared in advance in that. So the p-values on this were quite good, as you can see here. So we have a lot of confidence in the data. I want to go from the community to the dormitories. One of the things we got involved early with the university was to look at the dormitories. You know, could we use that as an early warning system? So what we did over the last summer was identify the sewer lines and began testing the sewer lines, the dormitories, right before the students started coming in. And we do this every day now. Every dormitory sewer line is tested of usually twice a week. And we bring them back to the laboratory here. We actually gone from testing about 100 samples of wastewater for viruses a year to 100 samples a week now because of the intensity of the sampling, both of some of the communities we test and also the university testing too. But it's quite feasible to do that. What we decided to do, because was to look at the level of the virus in the sewers coming from the dormitories, and we decided to establish a level of concern, like no virus, nothing to do. If we found like 10 to the 1 to 10 to the 2 per liter, we would create enhanced awareness. We recommended that the custodial crews enhance their disinfectant regime, but nothing else. If we went to 10 to the 3 to 10 to the 4, do random sampling of the students as they entered the dorm, see if they could pick up an infected individual. If it was higher than that, 40%. And if we got to 10 to the 7, all the residents were tested. We actually, after Christmas, we got up to 10 to the 9 copies per liter. It really hit some of the dorms hard. Well, what happened here is we, in August, students began returning to the dormitories in late August. We started our testing. Fall semester begins. We got our first positive sample from the Likens Hall on the 25th. It only took, it seems like a few days before some of the students started becoming infected. And then all hell broke loose after that. The virus started spreading throughout the university. But when the first lichen sample came in, we got the results at 6 p.m. that day, and they were confirmed. That was our first hit. At 10 o'clock, they called me asking for Dr. Pepper, who was the lead person in the group. And he was awakened by the president of the university going like, what do we do with your data? And so decisions were made to retest the wastewater and clinically test all the students the next day because the level was really high. So we collected 5 wastewater samples in a row every 5 minutes from the dormitory because we wanted to see if grab samples rather than collecting composite samples over a 24-hour were going to work. And we got the identical results basically in those 5 samples. So we confirmed the initial results. All the students were tested, and we identified 2 asymptomatic individuals who actually were removed from the dorms. And they both developed clinical cases, by the way, 4 days later. So we believe we stopped the virus from spreading. Just to give you another time frame here, we began sampling, we were negative, we got a large influx of students, and then the virus's level increased. The task force group decided what to do. We removed the 2 students, and the next day, the sewage went negative for the dorms. Interesting enough, one of the student who was in quarantine previously returned. We didn't get it results, but we got another student returned from quarantine from another site, and we did get a positive from that. So we noticed that even though they weren't clinically ill, they might have excreted a little bit, and then they went all negative after that. So we did learn, and pretty much followed what we've seen in the dorms, that if they go in quarantine for 10 days and they come back, we might get a weak hit of them because they're still excreting a small amount of virus. But we continued this pattern with dorms all over campus. By the way, I can tell you the party dorms, because they always had the highest hits all the time after the weekends. But what we did, this was the pattern we followed the lichen stamp. If we got a certain level, we went in and tested the students. If we found them, we removed them and quarantined them for 10 days. We brought them back, and we continued that pattern through all the dormitories on campus. And by October 10th, we had no more hits in the wastewater and no more infected students. And that held until the end of November, and they all went home for Thanksgiving, and and then we started getting hits again and started removing students, brought the level down, then they went all home. And then we repeated that same pattern again after Christmas to bring down that level. Interesting enough, some dorms like the Lichens dorm always were problem dorms, or we haven't traced it down, but some dormitories seem to have more issues than others. And we don't really know yet. We're investigating that, why we keep getting reoccurring cases in some dorms. And other dorms, well, one dorm, the nerd dorm, which is the honors dorm, is usually always negative, I guess because they don't socialize much. I don't really know. We analyzed this data, initially some of the results with the clinical results, and looked at our sensitivity and specificity. We really feel we're good about 82% of the time finding a student. Not all the times do we find a student. On a few occasions, we weren't able to find the student right away. We think we got them the second time, though, when we tested the dorm. But we feel very confident in the data in being able to have control the spread of the SARS-CoV-2 virus in the dormitories and that. What have we learned at sewage monitoring at the university? Well, grab samples in the morning seems to really work. We were originally going to do composite sampling, but the grab samples gave us the data we wanted. We could find as few as 2 infected students in about 327 people, pretty much pattern we've seen in the dormitories. No virus detected in the sewage after infected students were removed. Now, when they returned, we would get a slow hit sometimes because they were still excreting low levels of virus. 4-day lead time came through pretty positive. We had 4 days before they became clinically ill, because when we removed them, we would put them in quarantine. They'd be tested, and they usually would get symptomatic. Not all were symptomatic in about 4 days afterwards. It was pretty much a pattern. Social distancing worked. It brought down the levels when that was in force. Use of mask work brought down the levels, stay in place. We had a 2-week stay in place in the dorms, and it worked great. It lowered the level of the virus infection. What was interesting, the virus levels got much higher. They approached 10 to the 9 per liter of positive. We were really amazed. That all occurred after Christmas, by the way. It had a huge impact on virus in the wastewater. So what is needed with all this data? There's a lot of sampling going around the country in that, and several companies now have produced test kits. We've been evaluating those because those can dramatically lower the cost. These test kits are as low as $20 a test now. And some of them seem to work well just directly testing the wastewater right now. It may be because the levels of the virus is so high right now, maybe the reason. But tools are really needed for data analysis. That's what we've been focusing on with Brad Schmidt and his group, is to really get a handle on how can we use this data, develop the analytical tools. Can we put the data every day in a computer and use it in a predictive fashion, and how reliable it is in hunting down cases. But what's really going to be needed in the future, because health departments are really not familiar with these tools yet, or how they can be used and the potential for them. We provide our data to the health department, but they really haven't been able to get a handle on it because they're more trained in classical epidemiology, where they're waiting people to get sick and then trying to develop predictive models from that. So health departments do not know how to use the data, so that needs to be done in the future. And we keep finding potential applications of this, particularly looking at interventions, looking at regional. Some people have used it to target where to vaccine communities the first. Where are the highest cases? They've been dividing up their communities into different sections and looking at the spread of the virus throughout the community as it travels through it. Now, the National Institute of Health and CDC are going to set up a network of 100 treatment plants nationwide to evaluate the technology and that and look at the usefulness of wastewater epidemiology. I think it has a great future for use coming up now. I want to talk a little bit about, we've been asked a lot to work not only with trafficking of wastewater, but what kind of interventions we work in buildings and that in terms of controlling the occurrence of the viruses on surfaces or in the air. It particularly came to light with our wastewater treatment plant workers. Is the protective equipment adequate? Are the areas where they change their equipment protective? What about aerosols, inhalation of the viruses? What can we do to reduce those risks? Particularly our wastewater treatment plants are enclosed here for odor control. So do we have to worry about the buildup of aerosols of the SARS-CoV-2 or other potential viruses? Now, but you have to look at how we live today too. More people work in offices than ever before. About 70 to 80% of us work in an office. We travel further and more often than any generation in history. We spend less time cleaning than the last generation, actually about 50% less. And we spend more time in public places, the larger ones, larger airplanes, larger malls, larger offices. So really what all we're about is we share more common surfaces, which we call fomites, with more different people than any time before in history. As a result, you actually share more germs, bacteria, virus with more people than any time in history. So really what we do have here is a perfect storm for transmission of COVID-19. If you want to know why it spreads so readily, in that you're living in the perfect storm for a virus that's transmitted the way I showed in the next slide. By coughing, we believe coughing large droplets, aerosols, maybe to some extent, and fomites are involved in its transmission in that. Most of the evidence suggests it's really large droplets by which it's being transmitted, somewhat by aerosols. The role of fomites is still a question mark. We really don't have the firm epidemiological data. It's suggestive, but how much? 10%, 20%? We don't know. But surface contamination is always a potential risk because we know if this virus gets to your nose, it will be contaminated. So what we've been doing is finger transfer studies with the coronavirus 229E. What's the probability of you getting on your finger when you touch a surface and getting it to your nose and that? And there was no data on envelope viruses like coronavirus 229E. So we've been doing finger transfer studies, and it's very efficient from porcelain and formica. If there's a coronavirus on that surface of a glazed porcelain, like in a bathtub or a sink, you'll get 50% of the virus on your finger. And then we know from other studies, 10% will get on your nose if you touch your nose. And you touch your nose as a student, because that's where the study's been done, about 60, your face, 16 times per hour. Average adult is 24 times per hour. Children, it's 50 times an hour if they're under 6 years of age. So you do that more than you think. So every time you do it, there's a potential for you acquiring an infection with that. Now, we've been working a lot with the wastewater industry and also with Boeing aircraft here, trying to establish criteria for new innovative disinfectants. We're trying to provide solutions to spread of COVID-2 in commercial aircraft, airports, and they wanted a university partner to build confidence in it because they had some loss of confidence with the Boeing aircraft there. And also it fit well in with our looking at the wastewater treatment workers in that. And so we wanted to develop a pandemic toolbox of innovative interventions to use in SARS-CoV-2, largely looking at both air and fomites. What do you do to prevent the spread in a building? And we looked first at the antiviral polymeric silynated quaternary ammonium compounds are the most common cause of disinfectants. That's your Lysol product or disinfecting wipe you take home in that. And they've developed technology they can make them last 48 hours to 90 days on surfaces. You can put them on the surface. If you're old enough to remember the old odor eater socks, same technology. The silanated process binds the quats, which are very antimicrobial to surfaces. Now, fortunately, with SARS-CoV-2, it's an envelope virus. They're incredibly sensitive, and we found that some of these silanated quats last up to 90 days and still kill viruses and bacteria. Others last up to 48 hours for sure. So this gives you some additional protection to when you're not continuously disinfecting surfaces, because it's very expensive to continually disinfect surfaces all the time. And working with Corning, they developed the antiviral paint, which is basically a certain form of copper that's incredibly antiviral. Against the SARS-CoV-2, we've tested it and will kill the virus in 1 minute. Copper can be very antiviral, and it can attack the proteins and nucleic acids of viruses. But apparently, the whole art of it is developing the right type of copper formulation. So basically, and we're helping them get approved right now by the Environmental Protection Agency, which approve a number of these types of coatings. We've also evaluated a lot of these antiviral products in actual aircraft, because Boeing wanted to make sure, do they really work in an airplane? Will they work on your tray or in the airplane in that? And so we've been confirming both what we found out in the laboratory and in airplanes also, just to have confidence that this will work in an airplane. The other really area we're after, what do you do about the air? You know, HEPA filters you hear a lot about, and they use them in airplanes. So there's a lot of air protection in it, but you start putting them in schools and office buildings, they start getting expensive, not only from the cost of installing them, but they use a lot more energy because they're much finer filters. So they're very costly to operate too, energy-wise. So what do you do? So we've been looking at other interventions like bipolar ionization. That's fairly new. And in other words, is plasma, where you pass air through an electrical discharge. Now, it was known previously this works quite effectively if you use pure nitrogen or oxygen or hydrogen peroxide. You get a very reactive surface, but you can't be near there. But the technology is developed where they're passing air in a room through electrical discharges through it. You can be in the same room with this area because they're very low levels, and we're evaluating those for disinfecting the air and surfaces. The idea is you could be in an air, and if somebody sneezes, the ions would kill the virus and prevent the transmission from one person to another or contaminating surfaces. The other area is instead of using UV light at 254, which you can't really use in the air with a person looking at it. You can use it on surfaces. You could use it in air filtration systems, but you can't use it on people in a room. But 222 nanometer UV light can be used in a people when they're same room in the air to sanitize the air, because it doesn't penetrate the human skin and it's safe for the eyes on that. We're evaluating that to see we could really be used in the room. The idea is that you could have it in a room with people in it, and it would always be acting to disinfect the air and the surfaces in the room. They're really innovative technologies. One of the problems is none of these technologies can be regulated by the Environmental Protection Agency because they're devices. The U.S. Environmental Protection Agency can only register chemicals. So how do you test these devices? How do you ensure they're going to be work? So that's a real challenge, I think. Is coming up with technology you feel will give you assurance that these will really work in the real world. And we're trying to evaluate these in real world situations right now in rooms and see if they really work. Another thing is, what do you do? The question came up in the flight deck. They don't want to use chemicals because you don't want to short circuit an airplane when suddenly the landing gear comes down at 30,000 feet. Don't want that. Military had the same issue with tanks and other vehicles because they don't want to short circuit and accidentally launch a missile. And this equipment, they were always worried about chemical damage and corrosion too. So what do you do? So the idea came up, well, let's bake the cockpit here, if you would have it. Now, cockpits and military hardware are designed to take temperatures up to about 60 degrees centigrade. So we've been doing is putting heaters in with equipment, the same equipment that's in a cockpit, and putting SARS-CoV-2 on it and see how long it takes to kill it at 55 degrees centigrade. We've been looking, trying to get within 30 minutes to 2 hours so they can turn the plane around or use it overnight. Just put a heater in there. And then we've been testing it on the various surfaces that are actually in the flight deck of airplanes at 55 and 60 degrees. Unfortunately, relative humidity makes a difference. The SARS-CoV-2 is a lot more resistant to being inactivated at 20 degrees relative humidity rather than 55 degrees, which is more common for indoor. 55 degrees relative humidity, which is much common for indoor, unless you're living in Arizona. That's like about 8%. But so that makes a difference. So it's really, you had to do this very, very carefully to take into consider a relative humidity of the SARS-CoV-2, because it will survive a lot longer at low relative humidity than medium relative humidity. So those are some of the factors you have. So really what we've been trying to do, two things is one, develop predictive tools, measure interventions in communities, and track down cases using wastewater epidemiology, and trying to develop a toolbox so when to be used now in the current pandemic and in future pandemics, we can go there and pull out different types of technology right away. We'll have some assurance that they might work with the viruses that we'll be concerned about, because there's been a lot of innovation in technology today that we're evaluating against the SARS-CoV-2. We've been also evaluating UV light for wastewater and water treatment, and it works very well. SARS-CoV-2 is very susceptible to ultraviolet light, as it turns out. We've been developing dose response data for drinking water and wastewater right now. And we've been evaluating chloramines because they're used for the wastewater treatment for reuse here. And it's very susceptible to SARS-CoV-2, much more so than other viruses like noroviruses, which cause diarrhea, for example, or polioviruses. So we feel very confident anything that we've done with disinfectant with UV light or chloramines for water treatment will more than take care of the SARS-CoV-2 from the data we've gotten. And I'll be happy to answer any questions or discuss anything else relative to our work.
All right. Well, thank you very much, Dr. Gerba. I will open up I guess, Jamie, the chat window is where you guys are hoping to have questions, it sounds like.
Yes. Yeah, so if anyone has questions, feel free to send them in the chat to Shirley.
Okay.
If you accidentally send it to me too, I'll also see it. And
sounds good. Okay, so I do have a question from Dr. Pitts. Can the proportion of virus that is absorbed to biosolids be part of a model that increases sensitivity for wastewater detection?
That's a good question, because some work done by Yale University, they looked at the biosolids and you get a relationship with the number of cases, because the virus tends to concentrate in biosolids. That may work. One of the problems we ran into is you get more interference. You have to have a higher number of viruses for it to work, at least with the biosolids that we've tested. So yeah, you get a higher concentration. You can remove on the biosolids by remove as much as 90% of the virus on the biosolids. But the liquid was easier to treat, so we decided to stick with that, and it gave us the data we needed. So we decided not to do the biosolids, except to look at the survival of the virus in the biosolids.
Okay. Does that answer your question, Dave?
Yeah, that's great. Thank you.
I've got another one from Tucker. Does current qPCR wastewater testing detect and or differentiate among emergent strains?
Yes, it does. We're actually looking at different emerging strains. We picked up the UK one in one community we monitor back in late December. So it was already here in the US. And we're looking for the South African and the Hong Kong strain now in the samples we got, because by sequencing it, you can determine they're around. I can tell you the UK system, the one variant, because we do have the data now, appeared late December in the US. at least by wastewater analysis, in a large city which I can't tell you, but a large city.
Okay, I'm just gonna, there's been a lot of requests to share your presentation too. I was just gonna put that out there if people have to leave. Are you gonna be able to share your slides with the group?
Oh, yes, yeah, feel free to use them.
Okay, sounds good. So that one's answered. Okay, let's see. Why are the new variants more transmissible? I'm not sure if that's a question that you.
That's a good question. It's believed because there's more receptors they can attach to the cells of it. So in other words, if you get 100 viruses, you have a 50% probability of getting infected. But with the new variants, maybe it only takes 50 viruses or 10 viruses. And it can replicate and spread through your body more easily is the new. But you know, the real answer for that's not out. The other possibility, it may survive longer in the environment or aerosols, but those questions haven't been answered yet too. But they're doing that on the basis that you just have more receptors on the cells in your body for it to grow and reproduce and spread through your body.
All right, thank you. All right, does the ionization produce ozone that would be harmful in the air?
Good question. Yeah, some of them will produce ozone. You have to be very careful and measure the level of ozone depending on the device. You may generate ozone at low levels, and that's one of the concerns with the bipolar ionization is how well you control ozone production, because you don't want to be producing ozone with people in the room and that. We've looked at ozone disinfection of air, but you really can't have people in the room. It can be used to disinfect the air in a room if you want, but then the people have to exit the room.
All right, we've got one from Dr. McElmurray. You mentioned one dorm that seemed to struggle with COVID cases more than others. Do you know if there are more cases of other disease in the dorm relative to others as well?
You know, that's a good question. We could certainly find out. You can find any virus. You can find herpes virus if you want, but they won't let me look for that because we just signed up for doing that. The students, there's a release the students sign to go to the dorm. We have to have a release that we're doing the testing in that. And they do have the release for testing the clinical cases too. But you could look for any virus that infects human beings, by the way. You'll find any virus there. And that's a potential tool. In other words, we could monitor the true number of influenza cases every year if we want. Influenza virus is excreted in the feces, by the way, so you will find it there. Actually, even infectious form, they found it in feces. People just ignored that before. But you could look for anything. The hope is that in coming years, I'm going to guess they're going to be looking for influenza and the occurrence of other respiratory diseases. In the Netherlands, in some of the religious communities, they've actually used it to monitor for measles in the past. And if they get a hit of the measles virus, which they have in these communities, then they warn them because they won't do vaccinations because of their of religious reasons. And so, but then they can get a warning that you have to be extra careful, enhance hygiene practices in that, and try not to gather in groups. You know, I don't know if you know, measles is one of the most infectious viruses there are. If a person walks in a room with 10 people, there's a 90% chance that he'll infect other people. It's one of the most infectious viruses known. 90% probability if you're in a room with a person with measles of getting it.
All right, thank you. So now we've got one from John Norton. He says, hi, Chuck, by the way. Can you reference some good papers on the decay and attenuation of virus particles passing through the sewer? Trying to develop a model and cannot find much.
You know, I don't think there's really much on that. Nobody's really looked at what is the decay rate in the wastewater. Usually, you know, in a city community, the wastewater gets here within 24 hours, and I know the virus will remain viable for that long. We haven't really tried to model the virus in the wastewater in terms of how long it takes to get there, what's the attenuation rate in that. For the dormitories, we've been modeling that rather closely. We do have data on all the flow rates and that, so we can get an idea a little bit better, but we haven't really developed that for the wastewater plant. Other people are doing that and may be looking at that. But generally, the SARS-CoV-2 virus will not lose a lot of viability within 24 hours. It can survive fairly well for about 2 or 3 days, certainly, in wastewater.
All right. So I guess John said something about 52 hours was the longest stretch of sewer run. So just
You may vary with different communities. That's I'm just talking about our area.
Yeah.
Larger communities, some short. The dormitories, we're guessing it's only we're looking at minutes. But then again, what if somebody uses the toilet, the virus might be present for quite some time. You know, we try to sample in the morning, and hopefully all the students are taking showers and going to the toilet. So that it seems to be the pattern that we get because it seems to work quite well.
So there is some interest in, I guess, the relationships with the students during your study, and were they upset to be kicked out of the dorms and forced to get tested? Like, how did that kind
Gee,
of?
you know, I don't know. I haven't been involved in that area. I hope the quarantine dorms were pretty nice. I can tell you, one dorms, the hardest dorms to do anything dorm were the fraternity and sorority houses. They're always infected. If you don't feel you get enough exposure to disease-causing organisms, join a sorority or a Greek fraternity, because they seem to have the highest incidence of positive samples.
Okay.
Probably never be able to join a Greek organization after saying that, but anyway.
Okay. We have a question. Good afternoon, City. This is from, I'm going to say the name probably wrong. Bilal Walker. Good evening, or good afternoon, City of Detroit residents will be experiencing massive water shutoffs in 2022. Dr. Gerba, will this be useful as advocacy? A useful tool as advocacy.
In terms of water shortages, knowing the flow of it, I think the question is largely what would the flow in the wastewater systems be then? Is that going to impact it?
I'm not sure if, let's see if she's.
It may affect the
Shut
flow.
off, not shortage. Shut
Yeah.
off, not shortage.
Yeah. You know, it may affect the flow in the sewers. That may have an impact because, you know, it's probably related to the flow over time.
Shirley,
Because-
can I try to interject what I think they were trying to get at?
Yep, go ahead, Sean.
Yeah, I'm sorry.
I'm sitting right here.
Oh, there you
I
go.
can
Great.
interject if
Yeah,
you know. I
go
just
ahead.
didn't want to
Please.
be rude, but
Oh, go ahead.
I know how to do that. Good afternoon, everyone. Everyone looks lovely. My question is, Doctor, is that there's no reasoning with these people with these water shutoffs here in the city of Detroit. And I was asking, do you think your information would be good as my organization, Hydrate Detroit, can use this as advocacy to try to convince them not to shut water off again? Because as we know, with the COVID-19, it ravaged the city of Detroit residents on top of what we already were going through.
Mm-hmm. Yeah, that might be a good way. You know, one of the things this can be used with on a line is determining incidence in underserved communities. It's been already seen that certain areas that have been studied in other studies going on now, certain areas are experiencing more illness than others, and that be because of lack of medical care, lack of attention of providing the right services to these communities. And I hope in the future this can be used for things like that. You maybe not water availability, water use, that we can pinpoint underserved communities or neglected parts of the community that can be better served, because we'll have an idea of only the spread of the various illnesses, but the incidence of all kinds of illnesses. So I'm hoping in the long run, this can reorient health departments to target areas that of the community that have been neglected or not receiving proper medical attention. I think there's a potential for that, just from the data I've seen.
Okay, thank you for your answer to that one. There's still several questions coming in, so I'm just kind of moving through them. Here's one that says, have you been able to examine the effect of vaccination to wastewater detection, or is this still a future project?
Could you say that first part again? Sorry.
Have you been able to examine the effect of vaccination to
Oh,
wastewater detection?
we're hoping to now. Vaccination is spreading. The level in the wastewater is coming down, but I don't know if that's because of the effect of the Christmas is over. But the levels are coming down rather dramatically now. But we're hoping to see the effect of vaccination, because this is not a live vaccination. So we shouldn't see the virus in the wastewater. So we're monitoring that along with the vaccination program to see if we can get a correlation. It works really well with poliovirus vaccination program. So we're hoping to see the same thing here too.
Okay. So Dr. Schuster, I'm not sure if he's still here, but was mentioning that, and I'm not sure if there was a question involved, but that there's some quarantines and isolation here at the Wayne State dorms, monitoring for the virus in the dorms and midtown sewer sheds. Dr. Schuster, I'm not sure if you wanted to ask a question about that, or if you're still here.
Sure. Let's see. I guess I need to open up there. Great talk, Dr. Gerba. And I noticed there's a few other folks who are in a network across Michigan who've been monitoring dorm wastewater. There was a pilot project October to December of 2020. And of course that project is now complete, but we developed capacity for doing just as you're doing at your university, in conducting wastewater-based epidemiology. We don't have a lot of proactive ongoing funding for this type of activity, which I would consider to be a contemporary part of public health at any university at this time. But at least we had the infrastructure together and starting to move this forward a bit. And so hopefully, if the next COVID bill goes through, we can start to expand out and really work on the connection between not only the university sewer sheds, but also our midtown or greater downtown sewer sheds, and start to get at some of the community. Is there exchange? Are we seeing a vaccine effect? Can we start using the new variant targets to see what kind of spread we're getting from those new variant strains? So but yeah, I think we're all in this together.
That's a good point. Initially, with the stimulus package, we received from the governor $250,000 to do the work, which the university managed to do it. And then we helped the Yuma, the county of Yuma, where a lot of transient population. If you ate a head of lettuce last week, it came from Yuma, Arizona. And there was a lot of concern. So the governor office provided us $500,000 in the county, another $750,000. So there was a high degree of interest.
Yeah.
So a lot of sponsorship took place for this to happen.
Well, that's what we're looking for. It's it's good to compare your experience and make some arguments, to our own state governance, local governance. Thanks again for your presentation. Very comprehensive.
Thank you.
I want to follow up a little bit on that, and because you did mention, Dr. Gerba, about the kind of what's next and sort of what do we do with this information now, because the people in charge sort of don't really know how to work with the data and stuff. So how do you see, following up with Dr. Schuster, like you have all this great information and stuff, so how do we use it to benefit, I guess?
That's a good point. Basically what we said, what we really need is a huge amount of data has been gathered. There are thousands of samples collected across the country and even more around the world. Is trying to put it together in predictive models with all the variability of sewer flows, type of facility, number of people. I think that all needs to be analyzed and put together as the next step. And then we need to have workshops on putting it together. And then we need to develop relationships with the public health people, how they can use this data. I think this is an incredible tool for the future that's really been neglected, the potential for it, for managing and really justifying. I served on a board of public health for many years. We always had to justify our budgets. And now with this type of program, we go in there and say, you know, that we're going to need more vaccines coming up because we're seeing increases beyond it. We need to start vaccinating programs. We need to increase public health awareness of oncoming increase in infections and illness. So, but I think what it is we got to link the people that understand wastewater and organisms in it, in sampling and in all the intricacies of sewer sheds, and put it together in a format the public health people can use it, because they're just not familiar. They can't do that. We need the engineers and the microbiologists to get together with the public health people and show them how valuable a tool this can be in the future and that. So it's going to take an effort, but I see NIH and CDC is putting an investment into it. So I see it coming.
I add to that a little bit. You know, the purpose of a model is to synthesize, you know, data sets, and, you know, some sort of meta analysis could be made of, you know, this wide ranging, you know, extensive longitudinal data set. But what it boils down to is we're working with leading and lagging metrics here within a time series. And so if we were to look at a, you know, generalized time series model and the parameters of that model, you know, we may be seeing autocorrelation and, you know, common leads and lags, you know, throughout that model. So that may be one way of, you know, pairing that up with reproductive number and just getting a sense of, you know, as you pointed out, Dr. Gerba, there's the, there is some feedbacks that you're picking up quantitatively as far as the measures that are being taken. Even the simple measures seem to be very effective. And so that would be very, I think, very exciting. But that's the approach that we're taking here at Wayne is, you know, can we get to, you know, seeing patterns and the autocorrelations, or potential autocorrelation between time series data.
Yeah, that's a good point. Yeah, that's what's really going to need. It's going to be really valuable. I think it's from what we've seen here.
Look forward to working with you and maybe sharing some data.
Oh, sure. Be glad to.
So I can't remember, Jamie, where we're at in terms of time, but maybe time for one or two more questions. We've got one on sort of the, well, Jamie, where are we at in time?
We have a couple more. I mean, I have it going until 3:30, but if there's questions until afterwards, it's however long Dr. Gerba can stay and answer questions.
There's just, I think, a couple more right now, but
okay, that's fine.
There is a question from Theodora, and hopefully I'm getting this right, but that just sort of on what personal protective equipment you might recommend for waste workers.
Well, I think what they use now is adequate. You know, with their clothing that they use personal protective equipment, and it seems to be adequate. And they wear masks. And that the big concern we had was when they come back and they take off their gear in the locker rooms and they put it away or dispose of it. And that how to do that efficiently without contaminating the area where they're changing their protective gear and that. We've been working more on how to disinfect that room. There was a big concern by the workers that were contaminating the room. We're taking off our gear. Now they have procedures fairly well standardized in the healthcare community, not quite as well standardized in the wastewater industry. So we were evaluating initially ozone for doing it, but they didn't like that because then there's always a risk. You got to make sure it's all gone from the room. So we're looking at other options, mainly using persistent silanated quats in that for treating the room, because it was a concern. There was also a concern with the contaminating the vehicles with the virus too. And the workers felt they wanted some assurance that the vehicles that were traveling around after they looked at, inspected sewer lines and that they could be decontaminated safely and that. So we gave them some options. We were working on decontaminating vehicles or putting using silinated quats in these vehicles that would give them additional protection for at least 48 hours. Against SARS-CoV-2, that's all aimed at.
All right. Most of the rest of the questions I'm not sure if have been covered, but they're related to the variant strains. So just I'm going to ask this one to just see if it has been covered already. But have you been able to examine through sequencing different types of COVID variant strains known or those particular to the university?
We're doing that right now. Yes, I mentioned that. We have found the new the UK variant in one large community, and we're examining the wastewater from the dormitories and that, looking for it too. Now we're looking for both the Hong Kong, not the South African strain, the UK strain are the two that we're really looking at right now.
Okay. And then I guess there's just one, Dr. Pitts, I'm not sure if you wanted to speak to sort of following up on the vaccination question or not, and you're saying that it was interesting to see if the sort of rate could be corrected with.
Yeah, it's kind of a complicated thing. I was thinking about like vaccinations occurring maybe more readily in some communities rather than others, and whether you could correlate that with what you would see, say, measurements from the sewer.
We're hoping so. Teachers got preference here, so they've been getting vaccinated, and the students are next. So I think we might see it in the dormitories more than anywhere. I haven't seen it in the community yet. The levels are still fairly high. They're coming down, but they're still fairly high in the community right now. But we expect them, because there's still a large number of people infected, apparently. But we expect them to come down, and mainly the dorms, because they're going to be starting the students soon. They're on the list now coming up. So hopefully we'll see it in the dormitories, especially one dorm. We got one dorm. Somebody's infected every week. I don't know what goes on there, but they must have a good time every weekend, because every Monday morning they got a positive case.
Yeah, I was also thinking that maybe vaccines aren't reaching some communities as much as they should also, and might be able to actually see that effect too. I mean, in terms of what you're seeing in the.
That's our big worry too, because we know some communities aren't getting the coverage they should, and there's some cities on the West Coast that are monitoring segments of the community looking for that right now. They know certain areas of the community, and that's usually where medical care is not as adequate. Lower social economic groups, they have a higher incidence, and so they're watching that and seeing what happens, and hopefully that can be used in the future to target where the vaccine should be given first in a community.
Right. This has been very informative. It's really a great talk. I really appreciate it. Thanks.
Okay, well, I think we've sort of come to the end of our time. I don't know if Dr. Gerba, if you have time to stick around and have conversation with people that are interested in sticking around, but I am very grateful that you were able to come and speak with us. Thank you on the behalf of Healthy Urban Waters and Wayne State University. This is really promising to see that you can see this virus in the wastewater. 1 out of 327 students in it. It's amazing. So very kind of cool data. So and what you guys are doing with it. So Jamie, I don't know if you want to sort of give some housekeeping because I don't know what happens after this.
Yeah, sure. I just want to mention really quickly, everyone who signed up for the seminar who's submitted registered and whatnot, you will be getting, we'll be sending out a recording of this video afterwards, a link to the recording, and then you're automatically signed up for the rest of the webinars for this year. So you don't have to sign up again. And you should get the invitations for the rest of the webinars this year. But that's, I guess, all I have. But like I said, like Shirley said, if people want to hang around and talk and ask any more questions with Dr. Gerba, that would be great. But yeah, that's all I have.
Thank you. So you guys get hit by the snowstorm yet that was coming down, or is that still on its way?
It is bright and sunny here right now.
Oh, okay.
Yeah, it's very sunny here right now. We've been getting snow on and off for the last week or so.
So there wasn't another one. It already went through.
The Northeast got hit pretty hard last week, I think, earlier this week.
I think it's supposed to be coming maybe tonight or tomorrow. Like there's stuff coming.
Yeah, I thought I saw a big one coming down. But
Yeah.
Hey, sorry, Dr. Gerba, are you able to talk about the community? Like there is the study you did in some of the community, talk about how you are able to obtain health data, like for example, tests, like numbers of tests positive versus, you know, people who might be sick, so that you are able to compare those positive cases to the, you know, to the findings from wastewater. Is that, do you get barriers like based on a zip code, like based on how many people you might have? Because I have seen sometimes like what people don't realize is that the health regulation around the data does not allow to share, for example, data on some, in some particularity order that will make you know who actually was tested in where. So if we have a wastewatershed, and if we go down into a zip code, you can identify the two people who live in that zip code, that would be like a red flag. So like I wanted to know more about the communities you are working with.
Yeah, no, that's a good question. Yeah, the health department here of our county gives us the data, number of clinical cases per zip code. So it allows us to look a little bit at flows, you know, breaking it down in flows a little bit from different zip codes at least. But we do have it for zip codes, like for even for the university zip code and that. So I don't know if every health department does that, but at least in our county, we get it by zip code. We furnish the data to other cities in the Northeast and in the West, but I'm not sure what they're doing, all of what their data. But for ours, we're looking at it very closely by zip code to see if there's a pattern of it. We do composite sampling mostly here at the wastewater treatment plant. So we get a 24-hour or 12-hour composite in that. You know, but that's what hopefully we're hoping to analyze that in more detail based on the flows from these different regions, which the county seems to have available, the wastewater utility and that. Somebody asked, is there a correlation between other viruses and SARS-CoV-2? I don't know if there's a correlation, but we know we've been monitoring the wastewater here for viruses for 7 years, and you can see like norovirus season coming, which is the winter, and rotavirus, which is the winter, and then it goes away. And then the enteroviruses like Echinococcus, which cause fever and rashes, largely meningitis, come during the summer. But the seasonality of all viruses are interesting. Some viruses have no seasonality, like adenoviruses, the same level all the time, because people can get chronically infected with the kidneys and they excrete it in their urine, and then it causes respiratory infections. Yeah, some viruses, there's seasonality every year, others there's not. Correlation with SARS-CoV-2, that's a good question. I don't know, we haven't really looked at that. Yeah, I know the levels of influenza is a fraction of what it was. We do find influenza, I should say, but it's a fraction of what it was last year because everybody was practicing social distancing and face masks. That may make the difference. But a good question, on the zip codes. Some people are doing sampling, but just by zip codes in other cities in the U.S. So they're going to get a better idea than we are.
Okay, any other questions before we, I guess, say our final thank you to Dr. Gerba? Anybody
Sure.
else?
You guys take care now. Have a good evening.
All right. Thank you, Dr. Gerba.
Bye.
Bye.